Other ways of showing non-quantitative data. In this case, it would be patterns. Remember the bicycles we kind of looked at a few weeks back? Wasn't in lecture 4. This is the same thing. You can kind of see this is a 3D representation of the same data that was represented in 2D over there. Um, and then here they describe each kind of pattern and what it means. So you can see there's quite a lot of patterns you can look at. So the data is shown, it's numerical data, is how many bicycles were failing, when did they fail, when they were produced. But the thing is, if you're looking for patterns, that numerical data is not that important. It's the pattern that's important. So again, it's non-quantitative at this point. This is using size to represent how something about impedance or resonance for different parts of an electric circuit. It's kind of old, so I'm just going to skip over it. But also related to size, um, it, I think I'm going to play this model maker. I'm going to skip Cockpit for Engineers. These are videos from version 2 of the book. You can still find them online, but this video, Cockpit View, wasn't that interesting. So we'll look at Model Maker because it's more statistically oriented and again, non-quantitative. They're using size to give you an idea of regression. And then there's this thing that it's relationship to a maximum value. So that I only share my screen once, I will do the relationship with maximum value first, and then we'll watch this video for Model Maker. So selective magnification, it's basically using a map, an existing map, but distorting it in one way or another. So that's the selective part. This way, I can add one data dimension to that map. So for the most part, if it's a map of the world, and I have a few examples coming, you will see that they kind of keep the overall. This is South America, this is North America. You can kind of see Europe, Asia, Africa. But it doesn't look exactly like the map of the world. So, but the countries are next to each other like they normally are to a map. Uh, but they use a different magnification. So they basically change the size of a country based on some data dimension. The disadvantage here is that, yes, you kind of, which one of these is larger than in reality? You would have to know the real map to answer that. So if I showed you a map of a county, of no, all the counties in, let's say, Milwaukee, in Minnesota, then you won't be able to tell me which one has been distorted because you don't, if you have never seen that map, you kind of not going to be able to figure it out. So what this shows is, what's the other data dimension there? It's the population of the world, and this is the increase. And if I magnify it, I may be able to even read some of it. Who knows? So the size shows the share of the world in population, and you can see that China and India, they have a large population. They're bigger than they normally are. And then Canada, obviously very small. Geographically, it's a large country, but they don't have a large population. So this, you can see both the population based on the selective magnification, and then their relative growth or decrease on color. So I think blue is a decrease. You can see Eastern Europe was decreased. It's losing people. They don't have that many kids. And then all the Africa is probably gaining a lot. Africa and the Middle East is where you get a lot of population. But right now, or at least when this map was produced, they weren't a big chunk. Here's another representation. This has to deal with trade and industry. So the size, I think it's manufactured products that are being, so not natural resources, but manufactured products that are being exported or something along those lines. You can see Japan is really big here. Once to the side, and it's kind of hard, even hard to see, but Japan is there. Africa is really small. Eastern Europe, maybe not as big. Western Europe, huge. and then we have North America and South America. So selective magnification, I can see one extra data dimension by looking at it. So that distorts it. The next one actually distorts the image, but it shows more more accurate. So if you look at an electoral map and you see who won what state, normally they put a red they color red the entire state. But not all states are equal in terms of electoral college. There are large states here that only have a few electors, and then there's probably smaller states on the coast that have a lot of population, so they have a lot of representation. So what they're doing here, they took each state and they use selective magnification. And this, by the way, was when Obama won 2008. If you look at the map of the US, it kind of looks like there's more red than blue. If anything, they're equal. But if you start to use selective magnification, you kind of see what's happening there. Okay, and I will bring that up because there's a website, hopefully it's still there. I will look, you can see more results, kind of go through them quickly, and then I will go back to Model Maker while I'm still sharing my desktop. So 2016 election results, if you want to see the latest presidential, this is how it looks, plain and simple. If you start moving it, you can kind of see. Obviously, it was closer than it looks here. Otherwise, here it looks like the entire country is almost red. What else do they have here? So this is population. Sorry, this is population-wise. That's the first one. And it's almost 50-50. If you do it by the Electoral College, you have a lot more red. You understand, who is president. Then they actually do it by country. So you kind of see where there's pockets of blue inside of red. And here is, they look at percentages of people who voted. So if it was 70-30, it would be one way. If it were 49-51, it would be almost purplish. So you can see there's lots of purplish and kind of different maps, selective magnification. They just change it. You get a different feeling, get a different idea of, rather than this plain map of the United States. Because geography is not always that interesting in the sense that it doesn't play a role in elections that much as population and electoral college and individual parts of a state. Okay, so Model Maker, I'm going to let it play. Okay, 3, 2, 1.
Given data describing an artifact, the engineer may wish to select a mathematical model which describes that data. The contextual model maker supports that activity. The tool allows selection to proceed rapidly, at the same time encouraging exploration of the space of possible models. Each term in an equation is represented by a square in a grid. X1 is represented here, X2 here, and X1, X2, for example, here. Inside each square is a circle, which is black if the term is already included in the model, and white if not yet included. Here I'm adding and removing the x1 term. The radius of a black circle is based on the term's t-statistic from student's t-test. The larger this radius, the more valuable the term is to the model. The radius of a white circle is based on the term's p-statistic from the Fisher's probability ratio. Again, the larger this radius, the more valuable the term would be to the model. Embedded in the tool is a set of model fitting heuristics known as the rules of functional marginality. They state that a term may only be included in a model if all simpler terms which comprise it are also included. For example, x1 squared x2 can only be included if x1, x2, x1, x2, and x1 squared are already included in the model. A term having a grey background is one which fails the rules of functional marginality and cannot therefore be added to the current model on its own. The radius of its circle represents the value of adding to the model that term as well as all the other terms necessary to make its addition legal. Placing the cursor over such an illegal term highlights all the precursors needed in order to make that term legal. So here, if we were to add an x2, x4 term, these two precursors would also be added to the model. Clicking on the term x2, x4 therefore adds that term and the two precursors. The design of the contextual model maker is such that it shows the current model in the context of the p-values of all the other legal models one step away from it. But models need to be checked. These graphs support that activity. The first shows fitted data plotted against actual data. The closer the data fits to a diagonal line, the better the model. The second is a residual plot. Here we're endeavoring to make the blue line as straight as possible and parallel to the x-axis. Finding a satisfactory model is an iterative process. This histogram shows the goodness of fit of successive iterations. As the fit improves, the height decreases. Clicking on a bar can return the user to the corresponding earlier model. By adding one term after another, usually choosing simple terms with large circles, a model can be fitted quite rapidly. At all times, the user can view a large number of possible next steps. To summarize, the value of...
Okay, so what was non-quantitative? The circles. Obviously, if you look at the graphs, they were showing a lot more information about how far away, how good the fit is for that regression. But the circles, they were just giving you an idea how many different sizes you would see. It looked big, it looked kind of in the middle, or it looked really small, so you won't even bother with it. Again, it was quantitative data, but shown in a non-quantitative way.